Hello students, welcome to Akshar IIT Foundation classes. This is Ghaffar Mohammed, your physics faculty. Let's start our session. The last class, look at here. These are the questions, these are the formulas we already learned. So, this is a constant differentiation. This is a differentiation of constant. Differentiation of constant value, I'm recalling the answers, recalling the formulas. Differentiation of constant one is 0. So anything constant, if you multiply with the multiply with that value is 0 only. So now this is your general formula. So this is your general formula. This is your general formula, very important formula. That is nothing but differentiation of x power n. Differentiation of x power n is n into x power n minus 1. And based on that, they are given some problems. And these all things we already did. Here, I have given even these questions also we discussed. So now, this product rule also we have discussed. Now one more thing, very important formula it is. Look at here, very important formula. The important formula is quotient rule. So quotient rule also nothing but differentiation of any functions. Let's take two functions. Two functions are dividing. When the two functions are dividing, how you find the differentiation? You get here by using this simple formula, you can find the differentiation. Better see the formula. So differentiation here, y is a function, but the y is in which form? Which form? Division form. Means here u is one function, v is one function. The two functions are dividing. In that case, this formula is helping you. This formula is helping you. V du by dx minus u dv by dx by v square. This formula is useful for solving the problems. This is called quotient rule. Product rule also we did in the last class. That is called actually UV method. This is nothing but u by v method. UV method nothing but product. Any two functions are having in product. So to know the differentiation value, you'll use product rule. Here this is nothing but quotient rule. What is the quotient rule? Any two functions are dividing, are getting division. Then how to solve the differentiation value? By using this formula. The thing is, here the formula derivation, the formula proof not required. Keep it in mind. Once again I am telling, the formula proof is not required. Only the thing is, application is very important. According to our physics concern, application part of this is very important. So I will tell the examples, don't get worried. Better write down the formulas. So now one more chain rule. So this chain rule also very important here. This chain rule is also very important. This is a chain rule. So already you know dy by, so here dy by dx. This dy by dx you can write even dy by du into, sorry, it is not fair. It is not fair. I'll write, just write down, later we'll discuss the application part. Just write down, we'll discuss application part, don't get worried. So this is actually chain rule. Formula, just write down the formula. Now this based on this chain rule, based on this quotient rule, we'll do some applications. That is nothing but practice sheet. We'll do practice sheet. So directly I'll go for practice sheet. So now one more also very important here. The one more also differentiation of trigonometric function. Differentiation of trigonometric functions. So repeatedly these trigonometric differentiation will get while solving the problems. So better remember, better practice this differentiation of trigonometric function. You know trigonometric functions: sine, cos, tan, cot, secant, and cosecant. These are called trigonometric functions. So now look at here. Sine differentiation is what? Cos. Sine differentiation is what? Cos x. Differentiation of sine x is called cos x. Similar way, cos x differentiation is minus sine x. Differentiation of sine x value cos x, cos differentiation is minus x. Next to differentiation of tan. Differentiation of tan secant square x. Understand? Differentiation of tan is secant square x. And cot differentiation is cosecant square x. Cosecant square x. And similar way, differentiation of secant x. Differentiation of secant x is secant x tan x. Okay, differentiation of secant x tan x. Differentiation of cosecant x is minus cosecant x cot x. So this is your differentiation formulas, trigonometric differentiation formulas. Repeatedly you must do practice, okay, then only you remember lifetime. Now based on this all, let's do our practice sheet here. So now one by one we'll do the practice sheet. Now I'll go for practice sheet. See, this is your practice sheet 4. Let's do questions based on this practice sheet. Now see the first question, differentiation of pi. Differentiation of pi. Look at here, pi is a constant. Pi is a constant. You know already constant differentiation is what? 0. So answer directly 0. And next question is differentiation of x cube. Now look at here, we'll do differentiation of x cube, right? So differentiation of x cube, I am writing here the second question. Second question I am writing here, differentiation of x cube. D by dx of x cube. This is our question. This is our question. How do you solve this question? You know already, children, you know already differentiation of, let us write formula. Which formula we'll use here? Yes. D by dx of x power n formula is, you know already, d by dx of x power n, last class we did, that is n into x power n minus 1. So same kind, right? So here x we have, here x we have, power is 3, here power is n, only the thing, both are same. Now apply here, d by dx of x cube is equal to, what is the power here? The power is 3, so d by dx of x cube is equal to power 3, so 3 into x power 3 minus 1. So finally 3x square. So this is your answer. I hope you have understood. Similar way, the same practice sheet, let's do one more question. Yeah. Please open your textbooks, everyone. So based on the same practice sheet, let's do one more. This is question number 2, right? So this is question number 2. Now see question number 3. What is the question number 3 here? The question number 3 is, they given that d by dx of root x. This is your question, d by dx of root x. Keep practicing, do it, d by dx of root x. Now it is a very simple, you know, very simple. How it is simple? Look at here. I make you this is easier here. Root x nothing but x having the power 1 by 2 simply. X having the power how much, students? Power 1 by 2. So when it is power 1 by 2, it is converted into our formula. This total equation is converted our formula because the power x power having half 1 by 2. So use this formula d by dx of x power n formula. So when you write instead of x power half, instead of n, what we have? Half you are having. X power n, again n means half minus 1. So 1 by 2 x half minus 1, which would be minus half. This you can write 1 by 2 into x power 1 by 2, 2 into x power 1 by 2. This I can write 2 root x. This is your differentiation of root x. So can you tell me what is the answer here? The answer is, so the third option. The answer is what? Third option is correct. So similar manner, solve one more question. Now d by dx of 1 by root x. D by dx of 1 by root x. Now fourth question is d by dx of 1 by root x. This is your question. Now how do you solve this question? Easy, same kind. First change this function into our formula, into our kind of formula. So you can write first x power 1 by 2 d by dx of x power minus 1 by 2 d by dx of, now this problem is now going to be changed in our formula. Then you can apply here minus 1 by 2 because power is minus 1 by 2, x power minus 1 by 2 minus 1. Finally minus 1 by 2 x power minus 3 by 2. So this you can write minus 1 by 2 power x power 3 by 2. So do you have this one? So this you can write even minus 1 by 2 root x power 3. So root x power 3. So answer is think it is third option, again third option. Understand, children? Now solve this problem. Now I'll go for other problems. Now look at the fifth question. See the fifth question. The fifth question is d by dx of look at the fifth question, d by dx of x square plus 2x plus 3. This is your question. So now this kind of question, first apply this operator, differential operator to all the terms. Now if I apply the differential term d by dx of x square plus d by dx of 2x plus d by dx of 3. So now d by dx of x square, this is your formula. Apply formula. If you apply, what is the formula here? D by dx of x power n formula, that is n into x power n minus 1. Same thing, d by dx of x square, power is 2. So when you use power 2, you can write 2 x power 2 minus 1 plus, this is 2, you can write outside of the differentiation. Just do differentiation for x term. If you do differentiation for x term, the x having the power 1. So when x having the power 1, x power 1 minus 1 plus, this is 3 is a constant. You know, constant differentiation is 0. So it is 0. Finally, you will get 2x power 1, 2x power 1, because 2 minus 1 plus 2 into x power 1 minus 1. X power 1 minus 1 is x power 0. X power 0 value is 1. So finally it is 2x plus 2. It is your answer. I hope you are getting. Similar way, so they are asking that to find so sixth question, very important. Look at the sixth question. So sixth question. So read the sixth question, everyone. The volume of the sphere is given by V is equal to 4 by 3 pi r cube, where r is the radius of the sphere. The rate of change in volume with respect to r. The rate of change in volume with respect to r, and the change in volume of the sphere as the radius increases to 20 centimeter to 20.1 respectively. So this is the question. The radius is changing from where to where? First they are asking that, here there are two questions we have. The first question is, they are asking to find the rate of change in volume. First question is what? The rate of change in volume. The rate of change in volume. And the next question is, how much is the increasing in the volume? There are two questions we have. First, let me find rate of change in volume with respect to r. So the rate of change in volume with respect to r, you can write as dV by dr. You can write as what? dV by dr. So here V is the function. This function we are doing differentiation with what? Radius. To this function we are doing differentiation with what? Radius. In just before cases we are doing a differentiation of this function. We are doing differentiation of this function with respect to x here. But now the case is what? We are doing differentiation of volume with respect to r. That is nothing but the rate of change in volume with respect to r. Okay. Now this is our first question in that. Now you know already d by dr. What is the volume formula? 4 by 3 pi r cube. So in this question, you can write this 4 by 3 pi is constant. You can bring outside of the differentiation. Sorry, here we must take dr. 4 by 3 pi differentiation of r cube. It is nothing but the formula like x power n formula, differentiation of x power n. How much is the power? 3 is the power. R power 3 minus 1. So finally here 3 cancel. 4 pi r square is our what? Differentiation. Differentiation, the rate of differentiation. Now, and they're asking that what is the change in volume? What is the change in volume? They're asking. Change in volume, how do you find initial change delta V is equal to V final minus V initial. This is a simple formula. You know, final velocity, sorry, it's not velocity, volume. Final volume is 4 by 3 pi r final square, final cube, not square, minus 4 by 3 pi r initial cube. So now this in this formula, I'll take 4 by 3 pi common, r cube final minus r cube initial, simple way. So delta V is equal to 4 by 3 pi. What is the final radius? The final radius they mention as 20.1. So 20.1 whole cube minus initial value is 20 whole cube. So simplify it, you will have the answer. 4 by 3, they are asking the values, right? So pi, in terms of pi they mentioned. So now you can solve it here. Solve it. So directly you will get the answer as the first option. The first option is what? You will get 160 pi centimeter cube. That is a change in volume. So finally, this is your change in volume. This is your change in volume, and this is your dV by dr, rate of change in volume with respect to radius. These are the two questions. Understand, children? Next, look at the one more question here. Seventh question. I'll go for next question here. The seventh question. At the point 1.2 on the curve y is equal to, they given the question as at the point 1.2, 1 comma 2 on the curve y is equal to 2x cube. The gradient of the curve is increased k times as fast x, then k value. So simply they are asking that k value. The gradient of curve increased to x, increased to x. So they are asking to find what? They are asking to find k value. So gradient first, that is seventh question, right? Sixth question. No, seventh question. Now I am taking seventh question. They given one curve in the seventh question. They given some curve y is equal to 2x cube, right? 2x cube is the given the curve. So they are asking gradient. Gradient means with respect to x. So differentiation with respect to x will give the gradient. Then what is this gradient? When the gradient is become d by dx of 2 into x cube. So that is nothing but differentiation, right? So you can put 2 outside of the differentiation. So now do differentiation for x cube. When you do differentiation for x cube, 2 into 3 into x power 2 minus x power 2 minus 1. So finally, how much is the value? 6 x power 1. So here the differentiation is 6 times of x. The gradient is 6 times of x. So that what is the value of k here? K value is 6 simple. So what is the value of k here? 6. Because the gradient he said k times of x, right? When the gradient is k times of x, then k value become how much, students, here? 6. So that is the way simply will do. Now look at the one more question. One more question is 8th question. Simple thing. See the 8th question. X is equal to 2 plus 21t minus 4.9 t square. Find v is equal to dx by dt. Find a is equal to dv by dt at t is equal to 0.2. So very simple one. So first write down the equation here. First x value. X is equal to, they mention as 2 plus 21t minus 4.9 t square. This is the equation. First they are asking dv by dt. No, dx, v is equal to. That we mentioned already as dx by dt. So solve this dx by dt. Now v is equal to d by dt of 2 plus 21t minus 4.9 t square. So they are asking differentiation. So actually 2 is a constant. Constant differentiation is 0 plus 21. Because we are doing differentiation with respect to time, so we will get here directly 21. Exponent formula. Differentiation of exponent formula I am using. Minus 4.9 2 into t. So 4.92 means 9.8, right? So finally v is equal to 21 minus 9.8 into t. But they are asking the velocity at 2 seconds. So now you can put time value. So actually this is 9.8. 9.8 into t. So 21 minus 9.8 into 2. How many times? 9 times 9.8 into 2 times. That is, you can tell how much it is. 9 times you are doing. So that is 21 minus 19.6. Now you can subtract 21 minus 19.6. So that is about your what value? Now subtract 21 minus 19.1. 21 minus 19.6. 4. So here, how much here? 1.4. V value will get 1.4 meter per second. This is your answer. T 4.9. So this is only correct whatever we are doing. Next they are asking acceleration. Acceleration is nothing but dv by dt. So acceleration, already you know the thing is, velocity. Differentiation of velocity. Differentiation of velocity. Do it differentiation of velocity. D by dt of velocity 1 is 21 minus 9.8 into t. So A is equal to d by dt of differentiation of this is 21 constant. Differentiation constant value 0 minus 9.8 into differentiation of t is 1. So finally you are having the acceleration as minus 9.8 meter per second square. So this value is 9.8, this value is 1.4. I hope you got clarity how it is. So acceleration is what? So this is a what? Yes, it is the correct answer. I hope you got clarity how to solving the differentiation problems. So for today, children, I'll stop the session. So we have done with them. I will stop the session. Keep practicing based on these questions. Okay, bye bye.